feedback traditional control system, you have an error, and the system works based on minimizing this error, which is the output minus the reference input. And let's say usually use PID or other control methods. But in adaptive, you have, in model-based, you have a model that's kind of adapt itself and it tune itself based on the response. I'm not going to go into the detail of that, but just to know that control parameters can be updated to change the response of the system to match a desired model. And of course, it has some benefits. But here is the actual situation that's familiar to everyone. Let's say you have a cooling system like air conditioner, and in your greenhouse, let's say you want to provide temperature of 23. So this is going to be your desired, and then what in reality happens is that you have some fluctuations until you arrive at 23. And the problem with this, the drawback is that conventional greenhouse control with this method requires a substantial amount of control energy and effort to satisfy this control objective. So you don't want to invest a lot on electricity because otherwise the production wouldn't be efficient. What we came up, the idea is this model reference adaptive control. And the mathematics behind this is kind of huge, so I'm just pointing out that the reference here is a little bit more flexible, and the control objective is different. It's to achieve desired environments, which is, let's say, to achieve X% of data, these are the response actually, to fall between Y% of optimal comfortable level. So these are just numbers. Let's say you want to achieve 60% in the 70% of comfortable level. And of course, the ideal environment is 100% of data in the 100% of optimal control level. But before this research, what we had on literature, published research, only 3 tables to refer to. Let's say your sensor is reading greenhouse VPD, just a random number, 0.43 kilopascal. Now, what does it mean? At the vegetative gravity of tomato under sun condition. Before this research, what you could do, just look at the literature, one of these 3 references, and there is no 4 because I've already searched everything it could be. So one of these tables, the first one published by this 2005, it says that, okay, 0.43 is optimal. It's in a green area. The other one says it is here, it's not optimal. And I mean, it's kind of close to optimal. And the other is published by University of Florida 1994. And the other one says it is like yellowish, which is a little more accurate, and says it's acceptable, near optimal. But they don't say if it's good for tomato, cucumber, lettuce, okra, and what ground is it. It just says for greenhouse production. That's all you can get in terms of VPD. Next slide, please. Now, by putting this 0.43 kilopascal in the model, here you find 0.43, the computer finds it, goes to here, and it tells you that for tomato at the second gravity stage, under sun conditions, so it is specific for tomato, second gravity stage, and sun condition. That VPD is 80% optimal. So it is not either black or white, or it is just yellow color. So it is 80% optimal. And if you increase it into up to 0.51, it becomes 90%. And at this value, it becomes 100%. So that's how we validated the model. I recall from previous slide that literature one said it was optimal, the other said not optimal, the other was in between. Next one. Okay, also different locations in the country. Now, the question is that if you have different greenhouses, and also different locations, and also different crop, someone comes and you say, I want to come up with a greenhouse business. What structure do I use? It's not only for one small bale greenhouse, it's just hectares of hectares. So it really does matter what structure you use to give you the best solution. So what greenhouse structure do I use, and where do I start planting? Do I go put my business in the, let's say, Kinabalu or Seremban? In order to, okay, one simple solution is that we say, let's go plant, have a greenhouse, plant, experiment, and see the results. So maybe it will take 100 years and do this in every possible location, and let's see the result. But the other one is that to simulate. So we can simulate for every location in Malaysia. For this study,